which we are trying to use to collect the data from the sensors through the DAC board, which is the USB 4431 by National Instruments. And we have plugged in the wire for this sensor. Can you show this sensor? This sensor has been wired into this AI0, which is analog input 0, and we want to locate. This should appear over here. If there is no device here, it means you have to have some apply some power. This should turn on, the light should turn on, the blue light. And now you have to go to the add step, acquire data, DAC MX, because data acquisition MX analog input, we are looking at different variables, voltage, temperature, but our variable is acceleration in this case. So we will pop down, and IEP is for our piezoelectric accelerometer. And the first channel, as you can see, this is AI0, so we will click on AI0, analog input 0, hit OK. This will pop up, and you have to configure this according to our requirements. The most important thing is the sensitivity and the sampling frequency or rate. Right now, by default, it is 51.2 thousand, which is too large for our application, and I always recommend students to give around 2000 and hit enter, and then change the sensitivity to 98.3. If you take a look, the sensitivity is 98.3 for this sensor. So let me plug it in 98.3, and then don't worry about IX value. It by default it gives power, internal current, to collect the data 2.1 milliamps. It requires 2.1 milliamps to collect the data. If we give 0, then there should be no data. So everything is set. Only you change two things: sensitivity and the sampling rate. So for future labs, you should also focus on these two important parts: the sensitivity and the rate. Now let's go to the data view and pop down and bring it in over here and run it, and just run it. Now if you see there is a data coming here, this is the data line showing. Now you have to turn this on. This is the shaker. You see, now there is the signal is inside the computer. In order to log the data, we have to do some further steps. You can stop it and record. You can turn this off. This is the shaker, which runs at 159.2 Hertz. And I can show you before we go to the recording process and analysis. Go to analysis, frequency domain, power spectrum. This tells me what is the power frequency spectrum, at what frequency this is moving at. So I can bring this down, spectrum, bring it down here. So you can see, if you can, Khalil, if you can zoom this part, I want to show you this portion. What is this? It's about 159.2. So this is what we are looking for. If you run this and run this again, if you see this peak is telling me that the shaker is moving, or the signal is vibrating at 159.2 Hertz. This is our whole experiment. Our accelerometer is working nicely right now. The next thing which I want to explain here, how to log the data for a few seconds. If you go over here, recording option, and go to the stop condition, add the stop. By default, it calculates the data for 5 seconds, so I will not change it. I'll just keep this condition over there. And now we are in a good shape. We can run the program, turn this on. It is already turned on, and then record it. If you click on this button, record, and then it will ask you which data you want to record. So we need just this one. Don't worry about the remaining two, and hit OK. So it will keep lighting for 5 seconds and then it will turn off. You see it turned off, and now the data has been logged into the computer. How would you see the data? So let's go back to the playback mode. You see, in the playback mode, you can see what data have you recorded. It makes log. This is a log. You just plug it. You see the data is there, which has been recorded for 5 seconds, and if you want to run it, it is running for 5 seconds. And this is what we need. How will you export it to MATLAB? This is another question. So go to right click, export to Excel. That way you can copy paste from Excel. This is the data in the Excel. The one which we get. The first column is for the time signal. Second column is the data. If you want to be very quickly want to see the data, you just make a chart, insert, and make a chart or make a plot. This is very compact. We will zoom it in. Now, what I would do, I would go over here and import the data from the Excel file. How will I import it? This is another question. So first you have to save it. Control S. You have to save it. Suppose we save it on the desktop right now. We save it as lab 1. Okay, lab 1 today is the lab 1. Okay, now the data is been over here, lab 1. How will you import it into MATLAB? So if you go to the MATLAB and then import the data, you see this button, import data. Then it will prompt you, find out where do you want to find the data from. Go to the desktop, go to the lab 1, hit open. Now you see it has brought in the whole data. Then the only thing which you will change here, if you take a look here, is column vector. And now we want to start, it is the data from A1 to C. We don't need the Cth column. We just need we need the A and B starting from 11th row. So I will plug it in. I'll plug it in 11. I'll plug it in 11 and B. That's it. Now it had highlighted those two columns. So import it. You see the data is there. Acceleration G and Y unit label. Let me go back again to see what is this. Is acceleration G. You can change the name always for my convenience. What I will do, I will double click on this. I would say sensor 1D, just to keep the track what we are trying to see. And this is our time. And then I'm sorry, this is our time. And then import it. It will import the same data with the new names. Those are the new names, but the data is same. Now what you will do, if you have these two plots, these two variables, how will you plot them? Go over here, plot, and time versus sensor 1D. Sensor 1D. Maybe you can just plot it to see what do we get. You see the data is there. The same thing which you saw in our LabVIEW Signal Express has been transferred into Excel, into MATLAB. And now you want to zoom in. What is the time frequency? Time domain. You see, this is vibrating at 159.2 Hertz. Now, the lab it is showing you the time domain data. Okay. How will you convert it into frequency domain? How would you find out the frequency in the MATLAB? In order to find out the frequency, suppose I give a variable like gt, any variable. The command is absolute. Actually, the command is FFT of sensor 1D, and you have to take the absolute value, by the way, and then hit OK. Now it is showing you the plot of GT. Now it should show you the frequency spectrum. This is the frequency spectrum, you see, but right now this is not the current proper axis. We have to change the axis according to our sampling rate. Our sampling rate was our frequency sampling was how much? Do you remember? 2000 hertz. And let's make a frequency x. Frequency axis is starting from 0 to the length of the data. Let me make another thing. N is equal to length of the data, and the frequency axis, the data, sorry, the sensor. Data is our sensor 1D. This is the length, and the frequency axis is going from 0 to n minus 1, n minus 1, n minus 1 divided by n times, divided by n times fs. This is my frequency axis. This is my frequency axis. Now I would plot it according to the frequency axis times g. Now it should show you the exact 159.2. If you zoom in, or if you just mark it, you see what is this value? X-axis is 159.2. This is the whole lab which I explained in this video. And now if I zoom in, this is vibrating, this structure is vibrating, and so this is what you have to turn in our lab.